talking about it. But the industry for do-it-yourselfers sells about 70 million bags a year. We know that. And when you look at the pie, about half of it is straight fertilizer. The other half is combination products. And so when you look at the straight fertilizers, it includes starter and the various turf fertilizers. Probably the most troublesome part of this data is the fact that part of this pie is one of those fertilizers that we have a lot of concerns with, and that is the 1-1-1 ratio fertilizers. Triple 10 is pervasive as a product that's available through a lot of home centers and mass merchants. It's sold because of a price point, an entry point, all kinds of traditional reasons. People recommending it, for example. And that triple 10 that makes up a very small part of the pie actually puts as much phosphorus down on turf as all the rest of the pie combined. So its impact of one single product form is pretty pervasive. Weed and feed, about a third of the units sold. What's interesting, we get into a lot of discussions about insect control and the importance of trying to really make sure that people aren't doing this as a regular practice. Guess what? Homeowners don't do it. Less than 4% of the total units sold in the U.S. are combination product insecticide fertilizer. So they're not participating in that category to any large extent. Here's another thing. We started to look at more information from Chesapeake Bay because we do get a lot of questions on what are homeowners doing when. And this is a curve of monthly sales of bags sold per month, and this is total DIY industry. And you'll see that we have a peak in here in March and April, tailing off into May. Most of this in here tends to be either crabgrass preventer products or weed and feeds. In fact, if we dissect this curve and show you all the component parts, the crabgrass precedes the weed and feed by about a month, and then tails off obviously down into here. Most of this in the fall, which some people think doesn't even hardly exist, is actually fertilizer. And in fact, the amount of fertilizer sold in the spring versus the fall are fairly identical for straight fertilizer. What people are buying are weed and feed products and crabgrass preventer products to do two jobs at once to solve problems that they believe exist in their lawn. So again, this is a northern curve. When we look at stuff in the south, it looks a little bit different, particularly when we get into Florida. The back end sometimes gets almost as high, but it shows you what human behavior is. And this behavior is linked to a lot of things. One of the things typically is what we call spring lust, the need to get out and garden. And folks want to get out there and do stuff. And while you'd like to have them do a lot of other things, it's interesting the notion of gardening when it warms up in the spring, the need to do something. It's human behavior. It might not be exactly 100% agronomically driven. Here's where we start to dwell on some issues of context. Put this chart together to kind of look at the impact and where are we in the scheme of things, because like we talk in many areas, and our friends in Long Island are one of them that want to limit nitrogen to 1 pound per year. Most universities across the country for turfgrass recommendations go from 3 to 5 pounds of nitrogen per 1,000 square foot per year. Pretty standard recommendation. There's some tweaks here and there, but this is the sufficiency range that is recommended by and large. However, when you start to look at what homeowners are actually doing, the folks that are putting down 1 application per year are only putting down about 30% of the university recommended nutrient level to get to 3 pounds. So the vast majority of these homeowners aren't even close to the 3 pounds of sufficiency level. Likewise, folks putting down 2 applications per year are only getting about 60% of that 3 pounds. So the myth that we keep hearing all the time, that homeowners are over-fertilizing, we cannot find a systemic issue by looking at our sales and marketing data, participation data. 3 apps per year, they're about 90% rate. What's interesting when you start to look at the folks that are actually doing 4 apps per year, and that's the minority of applications. Where are they in this scheme of things? Because they're obviously over the 3-pound limit, but are their expectations at a much higher turf quality? And that certainly is a much different situation than the folks that are participating down here at the very low level. So another way to look at this, again, maybe is more bizarre, but hey, it's what we do. All those people we just talked about use about 360 million pounds of nitrogen per year on their lawns. The folks that are doing something, okay? And to get to the sufficiency level of 3 pounds of N, all of those folks would have to add on top of what they're doing today, 446 million pounds of N, just to get their lawns to that sufficiency level. So they're not even participating. That's not to talk about all the other 50% that aren't doing anything. So there's a whole raft of people out there that have to put on about 1.3 billion pounds of N just to get to the sufficiency level. So if you add all this stuff together, home lawns need to have about 2 billion pounds of N if you were going at the university recommended rate. Based on sales, they're only at about the 16% level. Why this becomes important begins to be part of the context. How do we approach what's being done? How do we approach the issues and manage the issues when we talk about water quality? And you can do the same kind of calculations for phosphorus. Same way. Is look at the sufficiency levels, look at the participation. Fortunately or unfortunately, nitrogen is a lot more dynamic than phosphorus. So again, the numbers are extremely low. One of the things we've gotten into over the years, particularly when we talk to a lot of municipal stakeholders and regional stakeholders, are what drives everything. And Stuart's going to talk a little bit later about models and things, but I want to show you one of the ones we're working with and trying to figure out how do we make an impact, because again, the lack of information leads you to some perhaps different pathways of action. If you go digging through the internet system, there's a bunch of information. This happens to be a chart off of the Chesapeake Bay program, and it's the nitrogen loads into the bay. And basically what the chart says is 10% of nitrogen load comes in from non-agricultural sources, implying urban fertilizer. Okay? Take it for what it's worth. Another chart that's on the web in the same kind of general area is USGS information about the amount of nitrogen loads going in through the bay on any one given year. I like to multiply and add things together. So if you look at the number, on average, there's about 215 million pounds of nitrogen going into the Chesapeake Bay watershed on an annual basis based on USGS research. Now let's take a look at some of these numbers and how they add and subtract together. So if you take that 215 and assume at 10%, that means that about 21 million pounds of nitrogen per year is coming into the bay through urban fertilizer. Okay? Well, we can go in and look at our numbers. These are sales numbers. We sell about 21 million pounds into the watershed. Scott's is about 50% of the market share for do-it-yourselfers. So do-it-yourselfers are putting down about 42 million pounds of nitrogen into the bay. Do-it-yourself volume and lawn service volume nitrogen is about the same. Generally speaking, you can kind of look at participation and rates and things like this. So that means that there's probably somewhere around 84 million pounds of nitrogen being applied to lawns in the watershed.
5 minutes.
Okay. So when you stop and look at this, on the surface, it's implying that 25% of all the applied nitrogen moves, 84 and 21, moves into the water. We've got a lot of speakers the rest of the day. You can ponder this, whether this is a correct assumption. However, when you look at the research data that's out there and all of the other assumptions, you got probably, say that 2% is on off target. That's about 1.7 million pounds that may be off target, may move hard surfaces, impervious surfaces, whatnot, natural